Hello everybody, and welcome to Green Technology, Spruce Up Your Boiler. This course today is going to be presented by Ray Wolfarth. Here is our GBCI course approval slide. You've got the course name, reporting number, and hours, and all of this information will also be repeated for you at the end of the course today.
Thank you. My name is Ray Wolfarth. I've been in the boiler business for almost 30 years. I've written a book, Lessons Learned in a Boiler Room, and I'm also a columnist for PM Magazine and PM Engineer Magazine on commercial boilers. And it's my pleasure to present this, and hopefully you'll have questions and things I'll be glad to answer. We're going to hold all the questions and answering them until the end of the presentation. System sizing, when you're sizing new boilers, that's what we talked about, was hydronic and steam are completely different from each other. The steam system, you have to size according to your connected load. What does that mean? Well, the location that's along your building, and you have to add all those together to see what kind of BTU content that is. And then you also have to factor in the piping that connects from the boiler up to the radiators or the fin tube radiation. In the old days, maybe 100 years ago when they were putting these in, that was about 50% more. For example, if you had 1 million BTU worth of in piping losses, so you would have to size your boiler for 1.5 million to meet that load. If you performed a heat loss on that building and you tried to your heat loss may only be 1 million BTU. So, but steam, you really have to connect to, you have to size it for the connected load, because the radiators don't care, what the temperature is. They just know that there's cold areas inside there that they're trying to heat. And one of the other things that we find with steam systems is that people will ask, well, why isn't the radiator heating all the way across? And the only time that it will really heat all the way across on a typical steam day is on a design day, which is usually the coldest day of the year. Now, hydronic systems or hot water systems are sized according to the heat loss, the complete opposite of what the steam system is. And you also, on those ones, you want to verify your pipe sizes and your flue sizes to make sure that the pipe going out to the building is going to be large enough to handle your new load and new boilers. What we did was around here in most of the areas, they used to go with 2 boilers each size for 75% of the load. The theory was if one boiler went down, the building would still have heat, and they'd be able to still provide some heat in there. The only problem is, when you're factoring in energy efficiency and the cost of fuel, is only 2% of the winter is when you require that full capacity of boilers. And at that point, your boiler system or your heating system is oversized by 50%. So, if you just do simple math, typical sizing of 2 boilers is 75%. So as it starts to warm up, you could be several 100% larger than what you need to be. And that's where modular boilers are going to be popular. We're going to see those in a little bit. This is New York City. Their design temperature is about 20 degrees outside. And if you're looking at a simple reset schedule, and if you're going to be replacing your boiler, most of your winter, as you can see, that boiler will be less than 90% efficient. It won't hit 90% efficiency until it hits 52 degrees outside. And actually 57 degrees is when it'll start to really turn into a 90%. Down at the bottom, where you've close to the design temperature, 32, 37, you're in a mid 80% efficiency. So you're going to pay a penalty, not a penalty, but you'll be paying more for a condensing boiler, which is typically 20 to 25% higher than a standard efficiency boiler. And if you're going to go to reset like this, it's a waste. Your condensing boiler, your 90% efficient boiler, will not hit that condensing part until it gets up to 52 degrees. This is